Sparse velocity V measured in feet per second, and acceleration A measured in feet per second.
Home, and I won't be back probably till like third hour. Is there another class I can complete these? You can?
Yes. Or any. If that doesn't work, you can really cover any class. You're welcome. There are continuous functions. The table above shows selected values of the functions. So for time 0 to 60, must there be a time where the velocity is -5 justified rates? Why?
Because the mean value theorem states that if it is continuous and differentiable, then it must go any rate of change is the instantaneous rate of change.
Okay. But not use mean value. Mean value is just
through nature.
Why? So you weren't here yesterday, so your brain wasn't tainted. That's the only theorem you know, right? Why intermediate value theorem?
-5 equals
Right? Intermediate value theorem was our test one. And the intermediate value theorem, remember, it's the boys going home from 7th grade theorem, right? The 7th grade, you go home, you're 5 foot tall, and you come back and you're 6 foot tall, somewhere in between. You had to be 5'5", right? On a continuous function, you have to hit every value in between. It is a much easier theorem than mean value. If you have the option, you want to use intermediate value theorem. On this one, you could do mean value theorem because you don't know the position. Because the mean value theorem gives you the slope, right? And I don't want the slope. I actually want to know, can velocity be -5? Does that make sense? So we've got to justify. So, first of all, don't forget to answer the question. On an AP problem, you'll get a point for that. So what's the answer? Yes.
You.
Yes. Why?
Because of the intermediate
Because
value.
it's continuous function. Does it have to be differentiable to
No.
So it's continuous function. And what's the intermediate value here? How do you word that? Before we say so, we'll still have one more big
Oh, if fx continues on AB, then L is the number between f.
So that's the part we need. -5 is between what? You said it earlier.
0 and -10.
0 and -10. I'm going to call that B of 35 and B of 50, right? So -5 is between B of 35 and B of 50. Therefore, by the intermediate value theorem, there exists, and you can say this a lot of different ways, but there's a C between 35 and 50. Where B of C equals -5. And again, the wording on that could be a lot different. Key things you need: continuous, -5 between B of 35 and B of 50. So those are the big things that you need to say. Okay, any questions on part C?
If we didn't know that and we just described it without using any of the things, we knew continuous, but you just straight up describe that in your own words.
But to get any points.
It depends on how they allot the points, and you'll see that when we start grading the AP packet where they allot the points from. One of the points would probably be saying intermediate value. So you've missed that point because you didn't say by the intermediate value. Otherwise, it depends on how they allot the points. Do probably get a point for saying yes. Just know I am. Okay, part D. For time 0 to 60, must there be a time when the acceleration is 0? I'm going to try the intermediate value theorem again. Okay? But the intermediate value theorem doesn't work. Why not? Never goes negative, right? So, based on the intermediate value theorem, my answer would be no. But I better look at mean value theorem first, right? And so, what do you think?
Did you say we couldn't do mean value theorem?
You can't on velocity because you don't have position. But for acceleration, can we use mean value since we have velocity? Now we're looking for the slope to be 0, right?
Does the mean value reflect the slope?
Mm-hmm. And so what is acceleration the slope of? Slope of velocity. Is there any time when the velocity slope is 0? And in my head, even though I'm saying mean value theorem, what am I really using? Rolle's theorem. Because I see the two places where the velocity is equal, so I know that the average rate of change is 0, so the instantaneous rate of change at some point must be 0. So, you can use Rolle's theorem or mean value for your justification. I'm actually going to show you both so that you'll see them side by side what the justifications would look like. If you can remember Rolle's theorem is a little easier on the justification. There will be a time a lot of people forget that Rolle's theorem ever existed because I will put mean value theorem on a mastery exam so you will know it quite well, and you'll kind of forget Rolle's theorem because I don't put it on a mastery exam. But if you like it, memorize it, you can use it. Okay, so we'll use by Rolle's and by mean value. For either one, what's the first thing I need to say?
Continuous differentials.
Okay, V of t is continuous, and
Different.
how do I know it's differentiable?
Acceleration.
It says both acceleration and velocity are continuous, right? Isn't acceleration the derivative of velocity? So it's differentiable because acceleration is continuous. Say that either way, right? Velocity is continuous and differentiable. By Rolle's theorem, I'm going to say V of 0 and V of 25. Therefore, by Rolle's theorem, there is a C between 0 and 25, or in the interval 0 to 25, where f prime of C equals 0. Sorry, B prime. I'm actually going to say B prime of C, which is so there's a place where the acceleration is. Okay, any questions about that one? So that's how you would justify by Rolle's theorem. By the mean value theorem, you still need to say we're continuously differentiable. But instead of this statement here, you would have to do V of 25 minus V of 0 over 25 minus 0 equals 0. And then, therefore, by the mean value theorem, there is a C in the interval 0 to 25. B prime of C. So, by the mean value theorem, this is the mean value theorem statement. Average rate of change equals instantaneous rate of change. Rolle's theorem, even though it really says the same thing, it uses a different. It's assuming the average rate of change because you have two things that are equal. So Rolls theorem is a specific case of mean value.
So when you say the premise, is that equal to acceleration? Is that what
It is. And the derivative, we learned that yesterday, the derivative of velocity is acceleration. Any questions about that? Okay, I'm going to stop the video. You have 30 minutes left in class. Work on something. You have AC packet 1 through 3. You have mean value stuff. Ask questions.